We are going to continue with increasing and decreasing and mins and maxes on the open interval from negative infinity to infinity, or whatever the domain restriction is for our given function. So the previous lectures were mostly about algebraic functions, so I thought today we would mix it up and do some more interesting ones, the trig ones, and we'll throw in a little exponential and a little bit of logarithmic in there as well. Okay, so to find my intervals of increasing and decreasing and my min and max, I know that I need to find the first derivative and find the critical points of the first derivative. So g prime of x in this particular case, derivative of x is 1, and the derivative of 2 sine is 2 cosine of x. So I'm going to set this equal to 0. So I get 1 plus 2 cosine of x equals 0. I will solve for cosine, so I'm going to move the 1 to the other side and divide by 2, and that gives me cosine of x equals negative 1/2. Okay, so that means essentially that I am looking for, I know that my cosine values are 1/2 at multiples of pi over 3, right? Okay, so this is not my answer because pi over 3 will give me a positive 1/2. Okay, so my cosine, if I think trig, right, cosine is x, so my cosine is negative in the second and third quadrant, so that means it will be at x equals 2 pi over 3, and the one down here will be 4 pi over 3. So those are my critical numbers. Now I'm really doing it on the entire number line. Now, so I know that every time I come around, so 2 pi over 3 is about right here, right? And 4 pi over 3 is about here, we'll say. Okay, so this is 2 pi over 3, and this is 4 pi over 3. Now, if I go backwards, right, I would also go negative 4 pi over 3. Actually, this would be negative 2 pi over 3 coming backwards, and this would be negative 4 pi over 3 up here. So every time I hit these, I'm going to get a critical number. So we're gonna expand our number line out here. So I know I'm gonna start with the 2 pi over 3. I always start with the ones that are in my, normal 2 pi, 0 to 2 pi interval. Okay, so then my next one, negative ways, would be, if I went backwards, this would be negative 2 pi over 3. So we'll go that way, and then we'll add if we need to. So then when I go this way, this is 4 pi over 3. So then to get up here again, so this would be really to get a coterminal angle here, that would be 2 pi plus 2 pi over 3, which then if I make this 6 pi, actually no, that would be, if I put this over 3, yeah, so 6 pi over 3 plus 2 pi over 3 gives me 8 pi over 3 will be my next one. Okay, so these are my zeros. And they'll go on and on and on, but hopefully we can go from there. Okay, so let's see here. So let's pick some nice numbers here. Okay, so between 2 pi over 3 and negative 2 pi over 3, we definitely have 0 here, right? So let's look at, so we'll look at we're going to put this here. So g of x equals 1 plus 2 cosine of x. Okay, so if I plug in x is 0, then g of 0 will be 1 plus 2 times, when cosine is 0, I get 1. So 1 plus 2 is positive, so it's going to be positive in this interval here. So, it can't change from positive to negative unless I hit, oops, I'm very sorry, unless I hit another 0. So since I found that 0 was positive, I know that it's positive the entire way in here. All right, so let's come back up here to so 2 pi over 3 and 4 pi over 3, so that's here and here. A nice number in between would be pi, so we'll put pi as our test case here, right? And if I do g of pi, actually, I'm sorry, I'm doing g prime here. G prime of pi, oops, that should also be g prime of 0. So I'm very sorry about not labeling that correctly. G prime of pi would be, let's see, I put in 1, and then I have, so the 1 stays, and then I get 2 cosine of pi. Now, cosine of pi is negative 1, so I actually get 1 minus 2 here, which makes it negative. So I know that my function will be negative here. So that means, now I know that this is completely continuous, right? It's an algebraic and a sine function combined, and they're both continuous. So when I add them together, the continuity still holds. Okay, so that means that in here I have an increasing, right? It means I have positive slope followed by negative slope, which is going to give me a max here. Okay, and now 4 pi over 3 and 8 pi over 3. So here, from here to here, essentially, I'm going to pass through here, right here again, which would be, in this case, 2 pi, right? Because 6 pi over 3 would be 2 pi, so 2 pi is in the middle. And g prime of 2 pi is exactly the same as g prime of 0, right? Because it lands in the exact same place right here, which g prime of 0 is positive. So now I have all positive values in here between 4 pi over 3 and 8 pi over 3, because it doesn't hit 0 anywhere else in there. So that means from here to here, I'm going to get a min here. Okay, so I'm going to have to go in both directions and see if I have a pattern. So my next one, 8 pi over 3 is here, right? So 9 pi over 3 would be 3 pi, which would be land here. And 10 pi over 3 would be my next one here. So that means I'm going to have a 0 at 10 pi over 3. Right? Now that is the same. So 10 pi over 3, so that means that basically 3 pi is in between them, right? So I'm going to pick all these nice ones that are nice and easy. Now, g prime of 3 pi, right, is equivalent to g prime of regular pi, which g prime of pi we found was negative. So it's negative in here. Oops. Okay. All right, so then that means I'm going to have a max here. All right, so then let's go back here. All right, so the next one from negative 2 pi over 3, so negative 2 pi over 3 is here. And so this would be then, to get up here, would be my next negative one, would be negative 4 pi over 3, okay? And so I'm going to pick a value in here, and so negative pi falls right in there. And I know that g prime of negative pi, right? So negative pi lands me here. Positive pi is exactly the same, so that's the same thing as g prime of pi. I mean, if you don't believe me, then you can do it all out longhand. But so g prime of pi we found was negative in there. Okay, so that means, so here's my next 0. So now following this pattern, let's see, that means I have, let's see, it's decreasing followed by increasing. And so it looks like I'm going to have a min here at negative 2 pi over 3, and then at 4 pi over 3, right? And I'm going to have maxes at 2 pi over 3 and then 8 pi over 3, and then it looks like it's going to go in both directions here, because my assumption is that back here it'll be positive again, so that means I'll have a max. And my assumption is also, I mean, I can check, obviously, that I'm going to get, but my trig is cyclic, right? So I keep landing on the same places, so I'm going to end up with the same thing. Okay, so I know that I'm going to have a max every time I hit 2 pi over 3, 8 pi over 3, right? And then if I go backwards 1, I'm going to have a max at negative 4 pi over 3. Okay, so let's see, is there a common? So if I think about from 2 to 8, I would be adding 6 pi over 3, right? So to get here would be that. And then, so basically, if I think of 2 pi over 3 plus 6 pi over 3, that gets me to 8 pi over 3. And then if I subtract 2 pi over 3 minus 6 pi over 3, does that get me here? And it does. So basically that means I'm going to have a max. Oops. Okay. Can you see all that? So essentially what I'm finding is that I notice a pattern that I'm going to have a max every time I add or subtract 2 pi to this, right? So the next one would be 8 pi over 3 plus 6 pi over 3. So my next max will occur at 14 pi over 3. So I don't want to just keep writing these out forever and ever. So basically, I'm just going to pick this first positive one and say I'm going to have a max at x equals 2 pi over 3. And then I found that every time I added 6 pi over 3, I got another one. So that would be, or subtracted it, so plus or minus, really 6 pi over 3 is 2 pi, so that would be at 2 pi k. I need another piece of paper here, sorry. So that would be at 2 pi k. So I'm going to have a max at every x equals 2 pi over 3 plus 2 pi k. Okay. Now we could actually find my x and y values for at least this one, right? Or two of them, but I'm just going to say for right now that we're going to have a max every time we add 2 pi or subtract 2 pi. And k really is an integer, right? So it's only positive or negative numbers, because if I add a half, then that doesn't work anymore, okay? So now I also notice here that, let's see, I'm going to, so I talked about the maxes, so that would be here, here, and here, and I notice that my mins are happening here, here, and here. And so the first positive one here, let's write these out. So 4 pi over 3 is the first positive one. That is my min, and I get a negative 4 pi over 3. Oh, no, sorry, that's a max. So this, my 2 pi over 3 was a min, right? I've already used that one, sorry. Min, and then my next min would be at 10 pi over 3. And I do notice again that if I add 6 to 4, I get 10, and if I subtract 6 from 4, I get negative 2. So basically, I'm adding or subtracting 6 pi over 3 again, which is 2 pi. So I'm going to have a minimum points, mins, at x equals, I'll just pick the first positive one, right, is 4 pi over 3 plus or minus 2 pi k. Oh, I'm sorry, I keep writing off the screen. This screen is so small, I'm sorry. Okay, so that's where I'm going to get my mins and maxes. Now this one's kind of complicated, right? I encourage you to actually graph this and look at it, right? So these are going to be, sometimes with trig functions, they're the same value. You're going to get the same y value every time, and other times you are not. Let's check it out, okay? So let me use a different piece of paper here. All right, so let's just go back to our g of x, okay? So g of x is x plus 2 sine of x. And let's see, we found that our maxes were at, we said maxes occur at x equals 2 pi over 3 plus 2 pi k. So let's do g of 2 pi over 3. So that means I'm going to get 2 pi over 3 plus 2 times the sine of 2 pi over 3, which is basically the square root of 3 over 2. And so this is going to be 2 pi over 3 plus the square root of 3. So I'm going to have a max at essentially 2 pi over 3 plus, or actually, that's my x value, and then I get 2 pi over 3 plus the square root of 3 is my y value. And just because of this x, so the next one would be at, what did we find the next one to be? If I add 6, that would be 8 pi over 3. Then this value is going to change every time. So every time I think I'm going to get just a slightly bigger value. So I encourage you to graph this and look at it and see how the mins and max falls. So sometimes they're cyclic and they just keep landing in the same place, and other times they're not. So this one is actually growing. I think it kind of does something like, I mean, that's a very, very bad graph, but I think it does something like that. And I'm going to guess that the mins will do the same thing, so I'm not even going to try. So I'm just going to say my max values occur at x equals 2 pi over 3 plus or minus 2 pi k, and my minimum values at x equals 4 pi over 3 plus or minus 2 pi k. Okay? So that was a very complicated one, but there's lots of critical numbers, and we had to do enough to see the pattern, essentially, for what it's going to do. Now, if I'm going to give you something like this, and I want you to actually give me the point values, I'll say, give me the point values for 2 of them, or something like that. Give me 1 min and 1 max value, and so on. So you don't, I mean, we're not going to evaluate a bunch of these, so All right, so let's try another one. Okay, so I've already written on the bottom of this paper, but that's all right. We can make do. Okay, so now we have cosine squared minus 2 sine of x, right? So the trig makes it a little bit more tricky because I get those, because of the way the unit circle goes, I get those, the constant, right, possible multiple zeros. So my f prime of x is equal to, now I just graded a bunch of exams, and I want to make sure that we all understand that cosine squared is really cosine of x quantity squared. So when I do its derivative, I have a chain first. So I have 2 cosine of x to the first times sine of x, okay? So this is my derivative of cosine squared. It's not sine squared, as some of you wanted to write that the derivative of sine squared was cosine squared and vice versa. All right, so actually, and the derivative of cosine is negative, so I forgot the negative sign. So my f prime here, the first term here is negative 2 cosine of x sine of x, and then I get minus 2 cosine of x. All right. So now, what do we have now? Okay, so we want to set this equal to 0 then, okay? And how do we do that? Well, I'm going to factor because I see a negative 2 and a cosine in both my terms separated by this minus. So I'm going to factor out negative 2 cosine of x. And when I do that, so to get this term back, I already have the negative 2 and the cosine, so I just need the sine here. And then when I multiply here, I've already got the minus, the 2, and the cosine, so that means I just need to put a plus 1 in here. Okay. So now I have two things equal to 0. I can set them both separately equal to 0. And so this gives me negative 2 cosine of x equals 0, and sine of x plus 1 equals 0. This one just gives me, if I divide by negative 2, it just gives me the cosine of x is equal to 0. Again, we're going to just initially start with just the ones between 0 and 2 pi to start. So I know that x is 0, or cosine of x is 0 at when x is pi over 2, 3 pi over 2. So I'm just going to start with those. But I know it's also at negative pi over 2 and negative 3 pi over 2, and my next one here would be at so on and so forth. And then sine of x is equal to negative 1. This is at 3 pi over 2, right? And then the next one, it only happens once. So that's the only one in there. But I know it will hit it every time I go around, right? So really, these give me the same critical values as this one. So we'll just use these here, right? So I'm going to make a big number line here. I'm going to have pi over 2 to start, and then 3 pi over 2. All right, so then if I think about this, right, so that's a terrible circle, but we'll go with it. So this is basically pi over 2, and then this is 3 pi over 2 here, right? If I go in this direction, there's pi over 2, there's 3 pi over 2. So my next positive one would be to come back up here. So this would be 2 pi, and then plus pi over 2. This is going to be 5 pi over 2 would be my next one. I'll go at least one in both directions here, maybe 2 backwards. Okay, so if I'm here at 0, and to get back here, this would be negative pi over 2. And then to get up here going backwards, this would be negative 3 pi over 2. So there, I've got 1, 2, 3 positive ones and 2 negative ones. We'll see what that does for us. Okay. All right, so let's see. We need to test in between these now. So a nice value between pi over 2, actually a nice value between negative pi over 2, which is down here, and positive pi over 2 would be 0. So that means I'm going to test out 0 here. And again, I'm going to use my f prime of x. Okay, so my f prime of x is negative 2 cosine of x times the sine of x plus 1. All right, so if I plug in 0 here, right, so f prime of 0 is going to give me, cosine of 0 is 1, so this is going to be negative 2, and then sine of 0 is 0, so then I get plus 1, so I get negative 2 times positive 1, which means it's 0. Or I mean, yes, of course, the derivative is 0, yes. The sign of the derivative is negative, okay? Actually, the derivative is 0 here and here, but my sign of the derivative at 0 and in between these two places is negative, okay? So that's at 0. Now I know, just to kind of go about it, this 0 is the same thing as 2 pi, right? And 2 pi is right here. So I also know it's going to be negative here. And then also 0, and if I go, 0 and negative 2 pi will land me here. So actually this out here, right, so actually this would go, the next one here would be negative 5 pi over 2. And so that would be my next 0. But negative 2 pi would be here, meaning that's also negative. So I'm going to kind of fill in a couple of them here as I go. Okay. So now I need 1. Let's see. Let's look at between pi over 2 and 3 pi over 2. So that's between here and here, right? So pi is a nice one right here. So I'm going to plug in pi here. And that's going to give me f prime of pi is, let's see, if I plug in pi into my cosine, that gives me negative 1, so I end up with negative 2 times negative 1, and then again, sine is 0 at pi, so then times 1. So I'm going to get a negative times a negative, which is positive, so it's going to be positive in this interval here, right? And so actually, I know that negative pi lands me at exactly the same place on my unit circle. Oh wait, did I... I'm sorry, that's positive, and I just filled it in as negative. So actually, we'll just change these. My pi was positive, okay? And I know that when I come back here, like here's where pi is, right? But if I go in the negative pi direction, that lands me at the same thing, gives me exactly the same values. So back here, if I choose negative pi as my, I can plug in these. It's all positive here, right? And 5 pi over 2. Let's see, so 5 pi over 2, so going around would be here, and so then the next place that I would test, if I was going to go farther here, that would give me a 0, would be at pi, and that is also positive. So I have a pretty good thing going here. I have negative, basically positive, negative, positive, negative, positive, and I am dealing with a completely continuous trigonometry function, right? Cosine and sine are continuous everywhere, so I don't have to worry about that. Sorry, my paper fell under the desk. Okay, so now I have this. So now I can see that I'm going to have this is a negative followed by positive, so that means I've got a minimum here, a maximum here, a minimum here, a maximum here, negative positive, and then I'm going to assume that I'll have this, right? Because that seems to be happening at each one. So let's see, I'm going to have max values at, let's see, so my max values occur at 3 pi over 2, 7 pi over 2, there's a max, negative pi over 2, and there's a max at negative 5 pi over 2. So I notice that if I add 4 to the top, right, and subtract 4, I get negative 1, subtract 4, I get negative 5. So essentially we can start, we're going to pick one, so 3 pi over 2, plus or minus, essentially, so if I add 4 pi over 2, plus or minus, right, that's how I got from here to here, and from here to here, and from here to here, it works. So basically 4 pi over 2 is just 2 pi, and we'll say k, where k is an integer. Now, the symbol for integers when you get into higher math is like a z with sort of a double thing here. So I just kind of like to say that k is an element of z. That's also a way of not writing out k as an integer. But we do kind of have to say that k is an integer, because if not, then k could be a half, and then that's might not land me on one of these pi, right? I'm only going to get this value when I'm straight up or straight down if I'm thinking unit circle wise. All right. So that's where my max values are going to occur. And I know that, so those are my max, my min values, right, are going to occur. They do occur at, I'm going to start from left to right here. The first one that we have here is negative 3 pi over 2. I get another one at positive pi over 2. I get another one at 5 pi over 2. And I'm going to, let's see, I think that is my last one on my graph there. So again, I notice that if I add 4 pi over 2 and I subtract 4 pi over 2, right, then I'm going to land back on here. So basically, I'm just going to pick the pi over 2 and say plus 2 pi k is where my minimum values are going to be. So let's try to plug in just one or two of these back into my original, okay? So let's just do, so to find the actual point to put on there, right, I would put this in, and let's say I'm going to try 3 pi over 2. So I'm going to plug in 3 pi over 2, just see what I get when I take it out. I need a bigger, there, let's move it up a little bit. Now you can oh, you can't. So I'm just going to rewrite it down here. So f of x is cosine squared x minus 2 sine of x. So this was our original function that we were dealing with. So now we're just going to see, like, do all the max and min values occur at the same height? So if I put in f of 3 pi over 2, then I know that cosine of 3 pi over 2 is 0, and then this will be minus 2 times 3 pi over 2 gives me negative 1, so essentially I'm going to get 2. So this was 3 pi over 2 was a max, so I'm going to get a max at 3 pi over 2 positive 2. All right, so let me do a min. So I know I'm going to get a min at, so my first positive one was pi over 2, right? And when I plug in pi over 2, f of pi over 2 gives me cosine of pi over 2 is 0. You really do have to know these trig values, right? And then sine of pi over 2 is positive 1, so I end up with negative 2. Okay. Now in this particular one, right, I got out firm values for both of these, and whenever if I put in, for instance, 3 pi over 2, the next one would be 7 pi over 2. These things that I put in here, they're exactly the same. So actually, I'm going to have all my max values will be when y is 2, and all my mins will be at negative 2. This one is going to be consistently up and down. So I encourage you once again to check out the graph yourself if you would like. Okay, so but we can just say that we're going to have maxes in this particular case at 3 pi over 2 plus 2 pi k comma 2, because there'll always be 2, and we're going to have mins at pi over 2 plus, or I should say minus, 2 pi k at negative 2. Okay? All right. So let's change gears. I'm tired of trig. Okay? Hope you probably are too. Okay, so let's do our first exponential. Okay? So we have f prime of x. Of course, we know if we're trying to find the min and max, we always take the derivative. I have a product rule here. This is minus x here. So I'm going to do the derivative of x squared first. So that's 2x e to the minus x. And then I have plus x squared. And then my derivative of e to the minus x will be e to the minus x times negative 1. So let me rewrite this as f prime of x equals 2x e to the minus x, and then minus x squared e to the minus x. All right, so I have a couple of different options here. I'm going to set this equal to 0. My options are either I can factor out, actually I can factor out a couple of things. I can factor out e to the minus x and an x, or actually I could think of it also like this, because e to the minus x, I could really rewrite this as 2x over e to the x minus x squared over e to the positive x, right? Because the negative exponent just means it's down here. And now I have a fraction with a common denominator, which I really like. So I can write it like that, equals 0. I could have also up here said e to the minus x times 2x minus x squared. I could have also factored out the x in the same step. Whichever one makes you happy is perfectly fine with me. But now I know my critical numbers either come from where my derivative is 0, so that would be where my numerator is equal to 0. Oops, I forgot the minus x squared equals 0. And I'm going to factor out the x, so I get 2 minus x equals 0. Do not think about adding that x squared and dividing. That is very bad. Just a reminder. So now I get x equals 0, and I get x equals 2 as my critical numbers that are 0. Now I also should check out any place where my derivative is undefined. That means I want to find out where e to the x is 0, and there is no solution to that, right? If I try to take the natural log of both sides, I get the natural log of e to the x, and I get the natural log of 0 over here, which means x equals the natural log of 0, which does not exist. Your calculator will tell you so, right? So this has no solution, right? If you think about what an exponential function looks like, it either looks like this, right, if it's a negative exponent, or it looks like this if it's a positive exponent. So it never actually becomes 0. It becomes very small, but it never becomes 0. So I only have the two critical numbers. Isn't that a relief after the last two examples? So my critical numbers are 0 and 2. I don't have any domain restrictions here, right? Because I know that e to the negative x can never be 0. So that eliminates any kind of domain restriction, and otherwise these are completely continuous functions. So if I plug in, let's do f prime. Which version do we want to use? Let's use the 2x minus x squared over e to the x. So I know that my denominator, no matter what I put in it, is always going to be positive, so that takes a little bit of the computation out of it. So if I plug in -1 here, so f prime of -1 is going to give me -2 and then -1 over something positive, right? It's just going to be e to the -1, but it's still a positive number. It's irrelevant. And so I get -3 over a positive number, which means it's going to be negative here, right? So it'll be negative in this entire interval until I get here where it's 0, right? And so then a nice number between 0 and 2 would be 1. So if I plug in 1, I get f prime of 1 is 2 minus 1 over something I know that is positive all the time, and that will give me a positive value, so I know it's positive in here. So that tells me for sure that I'm falling, negative slope, positive slope here means I'm going to have a min here at x equals 0. And let's see if it changes sign that's on the other side. If I do f prime of 3, I will get, so if I plug in 3 here, I'm going to get 6 minus 9 on top over something I know is positive. And so this is going to be negative over positive, which is negative. So it's here, it's negative here, and it's 0 right here. So that means I'm going to have a max right there. Isn't this one refreshing? I just have one min, one max. Thank goodness. Okay, so I know I'm going to have a min at 0, f of 0, and I'm going to have a max at 2, f of 2. All right, so we can figure out those values. I'm going to rewrite f down here again so I don't have to keep going back and forth. So f, which was what we started with, was x squared e to the minus x, okay? So if I plug in 0 here, I plug in 0 here, and I have 0 times 1, which is 0, so I have a min at 0, 0. And if I plug in 2, then I have 4 e to the minus 2. Oh, oops, I don't know why I wrote it like that. So then I'm going to have 2, and this will be 4e to the negative 2. Or another way to write it would be 4 over e squared, whatever. But there are my 2 points, this one being my min, right? And this one being my max, whichever version you like better is perfectly fine with me, okay? All right, so one more, and that would be logarithmic. Okay, so I end up with, I know I'm going to find the min and the max if they exist on the number line. Now logs also have a domain restriction, but you can maybe kind of tell, you can graph it, but this is completely positive. So I don't have to worry too much about the domain restriction in this case, but I can't take the natural log of 0 and I can't take the natural log of -1. So either I look at it initially or I need to check my values as I go. Now y prime is equal to, right? So 1 over this, x squared plus 2x plus 3, all over then the derivative of that, which is 2x plus 2. So this is very nice to find because it's all one nice neat fraction. So when I set it equal to 0, I get x squared plus 2x plus 3. And so I know I'm going to get a 0 for my derivative when I set the top equal to 0. So this gives me 2x equals -2, which gives me x equals -1 is a critical number. And then I can try, for time saving, like I should try this, but when you try it, you're going to get a negative number under the quadratic, if you use the quadratic formula. So this one does not give us any zeros, so the only one that we have here is -1. If you don't believe me, again, try it out yourself. So if I plug in, though I have -1 on my number line, so I'm going to put my test, it always goes back when I'm finding if it's increasing or decreasing, back in the derivative here. I only go back to y when I want the point value here. All right, so if I plug in, so x equals 0 is a nice one on this side, right? So if I plug in 0, then I'm just going to get 2 on top, 3 on the bottom, which is positive. So I know it's positive in this interval. I know it's 0 here, right? And so if I plug in, we'll say -3. So this one I've tried 0. This one I'll try -3. If I plug in -3, I get -6 plus 2, which is negative on top. And if I plug in -3, I get 9 minus 6, which is still positive, plus another number. So I get a negative over a positive, which is negative in this interval, because that's my only 0 there. So that means I'm going to have a minimum at x equals 0. And so I'm going to have a min at 0. And let's plug 0 back in here. When I plug in 0, I get the natural log of 0 plus 0. Actually, wait a minute, that wasn't, it's actually at -1. I'm very sorry. So I'm completely delirious there. So it's, the min is at -1, right? And then I plug in my -1. I was like, that doesn't seem right. So if I plug in -1, I get 1 minus 2 plus 3, and I get the natural log of 2. That's better. So there is my minimum point. I just plugged it in here. So there's my min. No max, just a min. All right, so let me just do one more of these really quickly. So let's do another exponential, because these can be a little bit tricky, over 2. So let's see if we can find the min and max here. All right, so now this one here, I'm just going to rewrite because this 2 is a constant. I don't need the quotient rule. I can just think of this as a half times e to the x plus e to the minus x. So this is, if I do the derivative, the half is a constant, so it can just sit here while I do the derivatives of these. So the derivative of e to the x is e to the x, and the derivative of e to the minus x is e to the minus x times -1, so this will become minus. All right, so now I need to know, when will this be 0? All right, so a couple of things here. So either I can recognize that if I plugged in x equals 0 here, I would get 1 minus 1 here, which is 0. Or I can always, right, I can divide by the half. That's irrelevant. So I have e to the x minus e to the minus x equals 0. I can always factor out the smallest exponent. So that would give me e to the minus x out here. And then to get to e to the positive x, I would need e to the 2x, because this is the point where you add the two exponents together. So that would give me e to the x, and then this would be minus 1 equals 0. So I get e to the minus x equals 0, and I get e to the 2x minus 1 equals 0. Now e to the minus x, so we just kind of talked about that if I just have e to a power, that's never going to be 0. So this one doesn't give us a solution. This one, however, I can check a little deeper. So I'm going to get e to the 2x equals 1. And now I can take the natural log of both sides. So the natural log of e to the 2x, e to the 2x equals the natural log of 1. And this gives me 2x equals the natural log of 1 is actually 0, which gives me x equals 0 as a critical number. So if I kind of eyeballed it up here and said, oh, look, if I plug in 0, I get 1 minus 0, or 1 minus 1, which is 0, then I've proved it now algebraically. So I'm going to put 0 here. And again, I'm going to go back to my derivative, which I'll rewrite. Actually, no, you can still see it. Okay. No, you can't. Not if I move it down. Okay, so here's my derivative, 1/2 times e to the x minus e to the minus x, right? So the half is positive, so I'm really not very concerned about it. So if I plug in a number, right, so there's my 0. If I plug in a number like -1, right, so then I would get e to the minus 1 minus e to the minus minus 1. So that would be actually e to the first would be which would really be 1 over e minus e. So I know that e is 3 point something and 1 over e is going to be smaller. So this is going to be negative. Put it in your calculator again if you don't believe me. Okay, so then if I try out positive 1, then if I put in positive 1 in here, I will get e to the first, and obviously the half doesn't really do anything, whether it's negative or positive. If this is negative, then a half times the negative is still going to give me a negative, so I just sort of ignored it. So then if I plug in e to the first over here, right, then I have e first and then minus e to the minus 1. So this time I have the opposite situation. So e minus 1 over e, so this is smaller, right? So then I'm going to have positive. So I know it's increasing on this side, decreasing on this side. Now I really didn't go through and say the intervals of increasing and decreasing. Hopefully I don't have to, that would have made the video even longer. And so now I know that I'm going to have a minimum here at x equals 0. And so I'm going to come back up here. And so I'm going to have a min at 0. And then I plug in, this is the only time I go back to original y. When I plug in 0 here, I get 1. And then plus, I plug in 0 here and I get 1 over 2, which gives me 2 over 2, which means I get a minimum point at 0, 1. Okay? So that's for all of you who complain that I don't do enough hard examples.